Alright, we're going to work a integration problem using partial fractions. So the problem we have here is the fraction with numerator 8x squared plus 8x plus 2. And that's all over the denominator 4x squared plus 1 quantity squared. We usually need to make sure of two things. One, that this is a proper fraction. So the degree up top is 2. If you multiply the bottom out, the degree would be 4, so that is a proper fraction. And also we need to make sure that we factor out the denominator as much as possible, but it's already done, so we don't have to worry too much about that. So let's go ahead and jump to our partial fractions procedures. So we'll have 8x squared plus 8x plus 2 on top. On bottom we have the factors 4x squared plus 1, and that's all squared. I'm going to leave a space because I'm going to go ahead and use the same line for solving this. But I need to set up some partial fractions. It only looks like there's one factor down here, the 4x squared plus 1, but it happens twice. So I'll use the singular version first, 4x squared plus 1. And then I also need every power that's there, so I'll also include a 4x squared plus 1 quantity squared fraction. So I'll have two fractions right now. And then I need to create the numerators, and I'll do it off of the singular. So the 4x squared plus 1, that's a second degree polynomial, so the numerator will need to be a first degree, so I'll use ax plus b. And for every repetition, I need to use the same setup, but with new coefficients. So for the other fraction, I'll have a cx plus d. Okay. Now I want to work on finding my a, b, c, d. So let's multiply through by the common denominator here, so they'll cancel out. So I'll multiply everything by 4x squared plus 1 quantity squared. So as I do that, and the fraction on the left hand side, it goes away. On the right hand side, the first fraction that has the singular in the bottom, I lose one of those on top, and on the fraction that was squared on the bottom, I'll lose all of it. So let's rewrite this, everything cleaned up. On the left hand side I have 8x squared plus 8x plus 2. On the right hand side, the first fraction left me ax plus b, and that's all times 4x squared plus 1, so I'm going to go ahead and full that out. So I'll have 4ax cubed first outer, so then I will have ax, then inner I will have 4b x squared, and then last I'll have plus b. And then from the second fraction, I didn't have anything to multiply by, so I'll just have cx plus d. Okay, so let's slide down to give ourselves a little bit more room. Well, let's keep that part up there so we can see it. So let's kind of figure out what our a, b, and c's are. A, b, c, and d. So first of all, look at what we have. The highest degree we have is an x cubed. If I look at that, on the left I have no x cubes. On the right I have 4a of them. So basically that tells me that a has to be 0. So going back, there's 4ax cubed. I've lined those up. So a is 0. So then let's go to the x squared terms. On the left I have 8 of them, and on the right I have 4b. So if I solve that, b equals 2. So let's just kind of color code that to help you identify it. There are all the terms you're looking at. Then let's go to just the singular x. So x, on the left there's 8 of them. On the right there is a plus c. Let's use a greenish color this time for no apparent reason. But you can see where things come from. We've already decided that a is 0, so that must mean that c is 8 if 8 equals a plus c. And then we have the constant. So on the left there's a 2, and on the right there's a b plus d. So let's see here. Let's use a orangish color. So we've already decided that b is 2. So if 2 plus d equals 2, that means d has to be 0. So we should be pretty happy that certain things aren't needed anymore. But go back up here to our partial fractions, ax plus b, and we'll fill in our a and b. So that was ax plus b, which will be 0x plus 2, so we'll just have 2 on top. And that's over 4x squared plus 1. And then separately, we have cx plus d, and that will be 8x. And on bottom, that fraction had 4x squared plus 1 quantity squared. So we're trying to integrate all of this in terms of x. All right, let's slide up so we got room. So let's separate this into two things and work through them. So 2 over 4x squared plus 1 dx, and then separately 8x over 4x, 4x squared plus 1 quantity squared dx. So we got two things to integrate, so let's see. The first one I believe is a trig substitution, but is one so common that we can just use our sheet. So the integration on our sheet says that the rule is the integral of 1 over a squared plus u squared du equals 1 over a tangent inverse of u over a. And there's a plus c there. But let's see what we have here. So ours is 2 over 1 squared plus 2x squared. And that's dx. So if u is 2x, then 2 is du, and then a is 1. So putting all that back together, ours will integrate to 1 over a, so that is 1, and then it will have the tangent inverse of u over a, where u is 2x in this case, and then it'll be a plus c, but we'll put a plus c way over here at the end when we're done. So let's kind of see what happens if we do the other one here. The second fraction was 8x over the 4x squared plus 1 quantity squared. That's a u substitution, so u sub. U is 4x squared plus 1. Du is 8x dx. And looky there, there's our 8x dx up top, so that's a du. And this part in the bottom is going to be our u. So we're trying to integrate 1 over u squared du. So that's integrating u to the negative 2. So that's negative u to the negative 1, which we can write as negative 1 over u. So let's just go ahead and go back to what our u was. So this will be plus 1, it'll be minus since there's a minus out front. So we'll just go ahead and put the minus in there. Minus 1 over 4x squared plus 1. My plus c is way over there. So let me move up a little bit so I can write them all together. So it looks like the complete answer here in a little bit more condensed form is the tangent inverse of 2x minus 1 over 4x squared plus 1 plus c. So we didn't have any endpoints, so that c is important. All right, thank you.